Okay, when you figure out the surface area, all that is finding out the area of all the sides of a figure and adding them all together. Finding the area of every surface and then combining them all together. Now, in many cases, we'll just be using formulas we had in the past, and in some cases, there are new formulas to either help us shortcut, or in some cases, like the case of the cylinder, cone, and sphere, we just really don't have those formulas from earlier. We need new formulas. And so here's how it works. I'm not going to do a bunch of problems for the sake of keeping this video short, but if you had a prism or a cube or any sort of rectangular shape like this, you would find the surface area of all the sides. In this case, this has 6 sides. You'd find the surface area of each one, add them up together. You could do the same thing with a pyramid, but there are some additional shortcuts. But if you have the information to find out the surface area of all the sides of a pyramid, then or the area of all the sides of this pyramid, then you can add them together to get the surface area. Now, as you can see with a cylinder, cone, and sphere, they have curved sections. So there aren't formulas from the past that we can use. We need new formulas to find the area of something that's curved. And we call that in the cylinder and the cone, we call that the lateral area. Okay. Lateral means sides. Your lats and your back are on the side. And so we're trying to find the area of this curved side. And in the case of the cylinder, we're going to use the height of the cylinder, which is the perpendicular to the base. And in the case of the cone, we're not going to use the perpendicular, we're going to do the length of the side. The length of the side. And in both cases, there's circles on top and bottom, and those circles have a radius. All circles do. And so that's the information we're going to need. So in the case of a cylinder, the lateral area is equal to, and I'm going to put LA for lateral area, is equal to 2 pi RH. And in the case of a cone, the lateral area is equal to just pi RL. So they're very similar. In this case, 2 pi r is the circumference times the height. Circumference times the height. And in this case, it's half of the circumference times the length. And again, the length is down the side of the cone, not perpendicularly. So that's how you find the lateral area. Well, to find the surface area, you just add that in with the other pieces of each shape. So let's do that in this case. The surface area of a cylinder, you start here, you've got the lateral area, 2 pi RH. You're going to add in the other pieces. Well, the top is a circle, and as we saw before, the circle area of a circle is pi r squared, but we have it twice. So I have 2 pi r squared that I need to add in to get the whole surface area. Now, in a cone, I only have one circle, so I have the lateral area, and all I'm going to add in is one circle, or just pi r squared. And again, I'm not showing you specific examples, but this, if you've got these numbers, you just plug them in and figure it out. Okay. As well, for the pyramid, there is a way to find the lateral area without having to find it of every shape. And this is how you do it. The lateral area of a pyramid. Now, know that this is not the whole surface area, because we still have to add in the base at the end if we want to find the surface area. If we want to find the lateral area, that is equal to 1/2 of the perimeter times the length. So again, just like the cone, the length is down the side, and the perimeter is the perimeter of the base. So you add up all the sides, and that's your perimeter. That's the number you put in there. And then the length is the length down the side of one of these faces of the pyramid. Plug that in there, multiply those together, cut it in half, and that's your lateral area. But again, as I said, the surface area will require you to add in the base. The way the book writes it is like this to try to keep things simple. 1/2 perimeter times length plus capital B. And by capital B, they mean the area of the base. Okay? And then finally, a sphere has curved sides everywhere, so it really just needs its own formula. And the formula for a sphere is this surface area is 4 pi r squared. 4 pi r squared. So if you find out the radius, you just plug it in and solve, and that's it. So again, I'm not doing any specific examples, but I want you to see the general idea. You're just taking the area of sections, adding them together. And some of those sections are new, like the lateral idea of a lateral area of a cylinder, a cone, and even the lateral area of a pyramid can be figured out. And in the case of the sphere, it just needs its own formula. All right, let's move on to volume. Okay, now, after all that complexity of different formulas and all that stuff, you'd be surprised that in volume, there's only really 3 basic formulas for the shapes we deal in geometry. There's a formula for if you have a right prism, a rectangular prism or a cylinder, something where the top piece and the bottom piece, like the base and its opposite side, are identical. So in a rectangular prism, that's that way. It could be a triangular prism, and it could be that way as well. So it could be a triangle that is, I'll just draw it. Something like this, where the 2 opposite sides are the same. So in this case, you have a triangle face, or in this case, you have a square face and a square face. In this case, you have a circle face and a circle face. And then they're connected 3-dimensionally, right? So hopefully that was kind of simple idea. But basically, if there's any figure where the 2 faces are the same, and you've got straight lines connecting those 2 sides that are the same, in this case, circle, circle, square, square, triangle, triangle, and they have to be the same. If this is a bigger circle than this, and this formula doesn't work, they have to be the same. Then the volume equation is simply the area of that base. So in this case, the area of a circle is pi r squared. In this case, the area of a rectangle is base times height. In this case, it's 1/2 base times height. So you find the area of the base, and then you multiply it by the height, the perpendicular height from one base to the other. So in this case, you would measure perpendicularly from one base to the other. And if it was slanted, you would still measure perpendicular as well. Okay? And then you can see here, these are ones that, unlike these that have 2 opposite ends that are the same, on these ones, you have one end and then a point on the other. So you have a base, and on the other side is a point. A base and a point. So here, basically like 2 bases that are the same. Here, one base and a point on the other side. Well, the volume equation here is you find the area of the base, and you multiply it by the height. Now, be very careful. It's not L this time. It's the height, which means you take the perpendicular measurement from that base to the tip. So if I drop a perpendicular measurement down to the base, it's got to be perpendicular to that base. Okay? So it's 1/3 base times height. So you can see these are closely related. This is actually exactly 1/3 of the volume here. Okay? And then finally, as always, spheres, they have their own equation. And in this case, the volume of the sphere is 4/3 pi r squared. Or squared, not squared, cubed, because it's volume. Pi r cubed. Okay. Now, let me just try to see if I can recap. If they have 2 identical bases that are connected, like in a cylinder or a prism or a triangular prism, it's the area of that base times its height. Again, measured perpendicularly. Height is always measured that way. In a cone and a pyramid, you take the volume of the base, and you cut it in 1/3, or you divide by 3, and then you multiply by the height, again measuring perpendicularly. And then the sphere has its own formula. You find the radius, you plug it into the formula, and you're done. Okay, now we're going to go see a few complex examples of these 3 ideas of area, surface area, and volume.